Math 3, Unit 9, Section 2 notes. So in the previous section, we talked about the what power function, which is this right here. And that what power, it was just trying to get us used to what we were doing without using some new math terms that you didn't know what they meant. So the what power is actually used in place of this word called a logarithm. So logarithm or logarithmic equations are the logarithmic functions are the inverses of exponential functions. That's why when we were doing this what power function in section 1, we were able to rewrite it into exponential form to see what our exponent answer would be. And that's what we're going to do in this section. We have exponential form and we have logarithmic form, and we can switch back and forth between the two forms. So in the previous section, you had, instead of writing what power, we're going to write logarithm. So those are the same parts right there. The b, the little tiny b here, is going to stand for the base, which in the example above is a 5. The n is going to stand for the answer, or the number, so that's all listed right here. So that's the 25. And then this equals 2, which is going to be equal to the exponent, because we're trying to figure out what exponent we raise 5 to get 25, and the answer was 2. So we're going to switch back and forth between logarithm and exponential. So let's try that with an example below, because that's where it makes the most sense. So what is the base in logarithmic form here? The base is the small subscript number. So that's a 5. The exponent is the what power. What power do we raise 5 to get 125? The power, or the exponent, is 3. So when we rewrite this in exponential form, we always write the base to the power equals the answer. But in exponential form, in logarithmic form, we have the base to what power, which is 3, gives us the answer of 125. Okay? So we are going to rewrite we're going to rewrite these logarithmic forms to exponential forms. So the base is 5, and we say, what power do we raise 5 to get the square root of 5? And it already gives us the answer, which is 1/2. So we raise 5 to the 1/2 power to get the square root of 5. And we know that because you can rewrite a square root as a 1/2 power, where your exponent here is 1, your index is a 2, and that's where the 1 and the 2 come from the fraction. All right, over here, a log is represented as the term what power. So what power do we raise 3 to? And it already gives you the exponent. You raise it to the -2 to get your answer of 1/9. And we know a negative means we move across the fraction line, which is why it moved into the denominator, and then you get a +2, so that would be 3 squared, which is 9. Rewrite the equation from exponential form into logarithmic form. So we're going the other way around. So remember, the base is the number, the big number that you're raising the exponent to. The exponent we already know is the smaller number. And then the answer should be written after the log of whatever base we have. You can write it in parentheses. It won't always be written in parentheses, but we can show it both ways here. So we say log base 2 of our answer, which is 32, equals the exponent of 5. because this would be what power do you raise 2 to get 32? Well, you raise 2 to the 5th power to get 32. And you can have the parentheses there, or you do not have to have the parentheses there. Okay. So then the next one, log of log base 10 of our answer, which is 0.001, gives us -3. All right. Now, like I said, you can have the parentheses there, or you don't have to have the parentheses there. But also, whenever you get a log base of 10, you'll see answers or questions written down in other sections where it does not list the log. We'll talk about it on the back side in a second. See how there's no small number there? So there's no base, there's no subscript number. That means your base is 10. Okay, and the reason for that is because we operate on a base 10 system. You have 10 fingers on your hands, and that's how we develop all of our numbers. We go in increments. Every 10 numbers, you get a new place value, if you multiply by 10, you get a new place value. So if it's not written there, then we assume it's 10. So another way to write this answer would be log of 0.001 equals -3. And again, the 0.001 can be in parentheses, it doesn't have to be. And then that number, if it's not written as a base, then it's automatically assumed that the number is 10. Okay. Evaluate the following logarithms. If needed, write an equivalent exponential equation. We're going to go ahead and write the exponential equation every single time. It's good practice. So remember that these are what power questions. It's saying, what power do you raise 6 to get 216? And they produce a power. They produce an unknown power, so I'm going to write that this is equal to x because I don't know the power yet. And so when I rewrite this, I'm going to write it as what power do you raise 6 to get or to equal 216? Okay, so the first one is in logarithmic form, the second one is in exponential form, and now I'm going to determine what exponent I need. All right, so 6 to the first power is 6. 6 times 6 is 36. And if I multiply by 6 again one more time, I get 216. So this would be 6 to the third power, which means that your x value here is equal to 3. Okay, so if I'm just evaluating the logarithm, I'm writing that this equals 3. So your answer would just be written as 3. I wrote x equals 3 because I did assign it a variable at the beginning. Either is fine. So you could also fill it in at the very end, saying log base 4 of 256 gives you blank, the number. All right, so again, we're saying 4 to what power equals 256. So you're going to have to multiply 4 times 4, 16 times 4 times 4. You should get 4 to the fourth power equals 256. So this answer is 4. Okay. You can write x equals 4. You can just write log base 4 of 256 is 4. All right. What power do you raise 5 to get 1? Log base 5 of 1, 0. 5 to the 0 power gives you 1. All right. Next one, 2 to what power gives you 1/4? Now remember with these fractions, I want to rewrite them with the same base first. So how do I rewrite 4 with a base of 2? 2 times 2 is 4, so 2 squared. But one's in the numerator here and one's in the denominator, so I'm going to move this one across the fraction line. What happens when you move a base across the fraction line? You should have answered that the exponent becomes negative, so this positive 2 of an exponent is going to change to negative 2. So the answer, or the exponent here, should be negative 2. So you can write equals negative 2. We could have done the same for the previous one, equals 0. All right, go ahead and move on to the back side. All right. What power do you raise 7 to give you the cube root of 7? Since we're in exponential form, you're going to change your radicals to exponents. So if I rewrite this, I have 7 to the first power, and my index is 3, so I rewrite this exponent as 1/3. Remember, your index becomes your denominator, and your exponent stays in your numerator. So this answer would be 1/3. All right, we talked about this one when we were looking at the other side. There's no base written down, which means I can rewrite this as log 10 of 10 to the 5th power. All right, and if I rewrite that in exponential form, that's going to be, what power do I raise 10 to get 10 to the 5th? That's really nice because, as you can see, the exponents match up in the same place. Your base is the same. As long as this number is the same, whatever you're raising it to should be equal. So x should be 5. So your exponent here is equal to 5, or you can write x equals 5. This is something new that we haven't seen before. You see this ln? That is called the natural log, and that's what you should state it as. So natural log. Natural log has a base of a specific constant that you can find on your calculator called e. So first of all, let's label some information that's new to us here. So this ln is called the natural log, or natural logarithm. This e is going to be a specific number on your calculator. You can actually punch it in, and it will give you the numbers, 2.7, etc. But we're trying to just figure out the exponent here. So we need to know what the base is of a natural log in order to figure out what number we're raising to what power, etc. So the base of all natural logs is automatically going to be this lowercase e symbol. This is a constant. It's not a variable. It's not going to change. It's similar to pi. Pi is represents a specific number. E also represents a different specific number. It does not change. It's not like x or y that we use as variables. So that e stays the same. So we're going to rewrite this. Natural log has a base of e. So what we're actually going to write this as in exponential form is, what power do we raise e to get the square root of e? Well, we can rewrite this into exponential form, e to the first, square root is an index of 2, so this would be e to the 1/2. And then you'll see that my exponents are 1/2. So x equals, or you can just write 1/2. We're just evaluating that logarithm, natural log. All right, same thing here. My base is e, so I want to write e to what power gives me 1 over e to the third. Remember, we want to move that across the fraction line so that we don't have a denominator anymore, which would actually change our exponent to a -3 instead of a +3. And then you can see that our exponent is equal to -3. If we write log base 2 of 10 in exponential form, we get 2 to the x power equals 10. This is for approximating logs. We don't know what number we raised 10 to, or 2, we raised 2 to what power to get 10, because 2 to the third is 8, and 2 to the fourth is 16. So it's somewhere in between there, but we're going to approximate it. So we know that it'll be between whatever those other two exponents are. So because 10 is between 8 and 16, your exponent will be between 3 and 4 because they're in the exponent place there. So I don't know if you can see that. So we're just going to state which two consecutive integers the exponent lies between. So basically, what exponent? An integer is a whole number at its opposite, so no decimal places here. All right, if I rewrite this as what power do I raise 3 to get 25, I need the numbers on either side of 25 that I can use 3 to a power to get that number. So 3 to the first power, let's go ahead and just write each of these out. 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27. Once you go past 25, you've gone far enough. So 25 is between 9 and 27, which means your exponent has to be between the exponents that produce the 9 and the 27, which are 2 and 3. So you state which two consecutive integers your answer is between. So your answer is between 2 and 3. This x represents 2 point something, closer to 3 than it is to 2 because 25 is closer to 27 than it is to 9. But you just have to tell me it's between 2 and 3, so it's like 2 point something. We're going to do the same with 7. 7 to the first power is 7. 7 squared is 49. We've already gone far enough because we've passed the 9. So if I write 7 to what power gives me 9? Well, 9 is in between 7 and 49, which means your exponent is in between 1 and 2, which are the two exponents that were given for 7 and 49. All right. 200 is quite a big number, so I don't think we should start with 3 to the first. We already have these 3's over here, so we can start with 3 to the third maybe. That's 27. 3 to the fourth would be multiplying that by another 3. 27 times 3 is 81. That's not far enough yet. 3 to the fifth, multiply by another 3, we get 243, which is bigger than 200. That means 200 is going to end up right between 81 and 243, which means if I'm saying what power do I raise 3 to get 200, it has to be bigger than 4 but less than 5. So our exponent is somewhere between 4 and 5. And later on in the unit, we will find the specific value of the exponent. find the y-intercept for the following functions. So y-intercept. What do we know about a y-intercept? Has to be on the y-axis, which means x equals 0, right? So we are going to plug in 0 for x and solve. All right. Parentheses first. What is 0 plus 9? 9. Good. Now, this portion right here. A logarithm is the inverse of exponents. So those happen around the same time. So we did parentheses. Now we're going to do exponents. Right now you're determining what exponent answers that question. So 3 to what power gives you 9? If we do this on the side, 3 to what power gives you 9, we know that that answer is 2. But log 3 of 9, we write the answer of 2. We don't write x equals 2 because we're trying to find out what the actual exponent is. It's saying what power do you raise 3 to get 9? I raised it to 2. Then the rest of my equation proceeds the same way. So all we answered was this log base 3 of 9. Now we continue to simplify. And what is 2 minus 1? It's 1. So what is the y-intercept? We're going to write it as an ordered pair. What do we use for x? 0, because it's a y-intercept. What do we get for y? 1. So we get this point 0, 1. All right. Let's try the next one. Again, we're finding the x-intercept, so we're going to plug in 0 for x. I'm sorry, we're finding the y-intercept, so we plug in 0 for x. All right, we're going to simplify. So we know 0 plus 1 is 1. But in order to evaluate log of 1, which is right here, we need to say what the base is. So if the base is not written, remember it is a 10. So this would be, what number do you raise 10 to get 1? What number do you raise anything to get 1? 0. 10 to the 0 power equals 1, so then we're going to add 3 to that. And 0 plus 3 is 3, so y. So this point is 0, 3 for our y-intercept. All right, that's it for section 2. Please make sure you check your homework or your assigned problems for worksheet 2.